Hello everyone, this is Amit Arya working in ECB College, Bikaner. Today I explain Myhill-Nerode theorem. There are two ways to reduce the states of any DFA. First one is partitioning method, other is a table filling method, which is also called Myhill-Nerode theorem. So we will start the things with the second thing, that is Myhill-Nerode theorem, in which we have this DFA A, B, C, D, E, F, in which C, D and E are final states, and A, B and F are non-final states. Before going on, we must understand the steps that are required to understand this table filling method. First step is we make the pair of states. Here I have drawn a table in which we have drawn the states A, B, C, D, E, F in a row wise and in a column wise, so that we can draw pairwise values. You can see here this is AB, because this is the comparison of AB. Here is a comparison of AB, and here is also comparison of AB. So this square and this square both are same. Look at this. This is the comparison of AC and this is comparison of AC. So this both squares, this and this, are also same. So this is just the duplicate. This part is the one, duplicate. So this duplicate part we simply discarded. We put simply cross here in the case of AA, BB, CC, and similarly to F and F. So this part we have to fill. How to fill this? Look out this thing. Fill the table such that one is final and other is non-final. We look the states in which if we got one is final and final, we simply put a right mark there. Here A is non-final state, and similarly B is also non-final state. We left it empty. Here A is non-final state and C is final state. We simply put it right. Here A is non-final state, D is final state. We simply put it right. Here A is non-final state, E is final state. We simply put it here. And here A is final state and F is again a non-final state. We left it blank here. We got how we get the value here. We will see it later how we get this value here. Now move to the next column. Here C is final state and B is non-final state. We put it right. B is non-final state and D is final state. We put right here. Here B is non-final state and E is final state. We put right here. Here we will see, check further how this value we get. Here C is final state and D is again a final state. We left it empty. Here C is final state and E is also final. We left it empty. Here C is final state and F is non-final state. We put right here. This D, in the case of D, is final state and E is again a final state, so it remains empty. Here D is final state and F is non-final state. We put right here. Here E is final state and F is non-final state. We put right here. So this up to this point we got this table where these two values here are also empty. Okay, so this is the first step. Fill the table such that one is final and other is non-final. Now what will be the second step? If transition of the empty state move to the state where there is a write, even if for the one input put it 1 there. What it exactly mean? We check the input for both 1, 0 and 1, and if for any input there we got as a write, we put simply a write. We first check this thing AB, A on 0 and B on 0. A on 0 leads to B and B on 0 leads to A. So we got the set AB. So AB, so we check AB, it's empty, so we left it empty. A on 1 leads to C, B on 1 leads to D, CD. We check the state C and D, C and D and C, which is empty, so we left it empty. This we left it empty. Here we have what we have, D and C. Okay, D and C. Here we have D and C. So let us find out D and C. D and C, and also for D, 1 and C, 1. D on 0, D on 0 leads to E, which is E, and C on 0 is F. So we got the set EF. EF. What is EF? D and D on 0 is F. This is F. Is not E, this is F, and this is also F. So this is F and F. F and F is simply a cross, so we left it empty. Similar is the case with these two. This is this will remain empty and this will remain empty. We consider now these two cases. Now look this, AF. A on 0 leads to B. A on 0 leads to B, and F on 0 leads to F. F on 0 leads to F. A on, this is 1, A on 1 leads to, A on 1 leads to C, and F on 1 leads to F. So what we got? BF. Other pair we got CF. Let's check what is BF. BF and B, which is empty here. This is empty. Okay. So what is CF? CF, F and C. But CF is, there is a write. So we have to this is what it says. If even on only one input, you put it right there. So for this CF, there is a right. We got a right, so we simply put a right here. Okay. Next we move to the BF, that is BF for this cells. BF on 0 leads, B on 0 leads to A, and B and F on 0 leads to F. B on 1 leads to D, and F on 1 leads to F. Okay. We got now 0 and 0. So AF pair, from here DF. Let's check. AF. What is AF? AF. There is a right here. We put simply a right. So here we get right, and here we right. This step is completed. Now this will repeat. We will repeat this step first and second step, and check whether two consecutive times, if we got the same table, then we simply stop. So again, if we repeat these steps, we will got the same table. So I will not continue this thing. We will simply get the F and F here. So let's draw. Third step is draw DFA. How the DFA can be constructed. So here what we have, empty cells. We just combine the empty cells. AB. First is AB. Next is CD. CD. This is actually AB, CD, E or CE and CD, ED. Okay. So AB, this we can see here. CD, C and D we have seen here. CE, this box we can see here, and ED we can see the box here. These three boxes can be combined into one. So I have written here CDE, combine these three states as one, and the last state is F state. Here I put the state F. Now AB on 0 will remain on itself, that is 0. On 1 it goes to the CDE state. CDE on 0 will remain on itself, and on 1 you can check here, on 1 it will move to F. From these three, this one, it will move to F. F is 1 leads to F. On 0 and 1 it leads to F. So this is the minimum DFA. This is the minimum DFA, and this is the actual DFA. It contains it 1, 2, 3, 4, 5, 6. It has 6 states. It has 1, 2, 3. It has 6 states. So this is how, by using table filling method, that is Myhill-Nerode theorem, we have converted 6-state DFA to 3-state DFA. Thank you for watching. Meet next time.